Hello, everyone. Thank you for joining today's Koringo Tech Tuesday webinar. The session's topic is performance testing for object storage. I'm Ryan Meek, Principal Solutions Architect at Koringo. Today, our guest is Michael Q. Brame, our Quality Engineering Lead. Q and I will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have a couple of resources available via the attachments and links window on your view screen. If you have any questions after the webinar, you can always reach us by email at info@koringo.com. I've been with Koringo for most of the company's lifespan and have worked with Q in a capacity as developer, tester, trainer, sales engineer, product manager, and now Principal Solutions Architect. Q, why don't you introduce yourself?
Thanks, sure thing, Ryan. And you have had a lot of hats. Like you, right. I've been with Koringo for most of the company's lifespan, and I currently lead our quality engineering team. In my downtime, I enjoy brewing beer and wine, 3D printing, building stuff, and watching anime with my son.
Fantastic. Well, let's start with a little bit about Koringo. Koringo was founded in 2005 to change the economics of object storage by designing software from the ground up to solve issues associated with relentless data growth. Koringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Koringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Labs, UK Science and Technology Facilities Council, Texas Tech, US DoD, Brazilian Court System, British Telecom, and hundreds more worldwide. Today, we're going to cover testing environments as well as tools and tips, questions, and a wrap-up. But the main thing will be the STFC Jasmine Supercluster use case, which is a great instance to dive into the details of performance testing object storage. So Q, why don't you take it away?
Thanks, Ryan. As we said, there we go. As I said earlier, the example we'll go through today is our performance analysis that we performed with the Science and Technology Facilities Council in the UK, or STFC. The Rutherford Appleton Labs has deployed a super data cluster known as Jasmine, which includes a supercomputer's high-performance network and storage, but without quite as much compute power. Data sets come from various projects and instruments, including 12 ESA satellites that stream up to 10 terabytes of data daily. And many of the data sets are just too large to move around easily, so Jasmine enables the scientists to bring the processing to the data. In this environment, the need to support a large community of researchers, universities, and users, along with the constantly increasing capacity, necessitated a shift away from traditional POSIX to RESTful object interfaces. We'll bring up a slide here about the testing environment we worked with. And here's the testing environment. It contained an extremely robust set of clients, switches, and Swarm storage nodes. There's an ample set of clients at our disposal, and the network itself consisted of super low latency, non-blocking switches with 100 gigabit ports. The switches were organized in a leaf spine network so that every endpoint was only 3 network hops away, and there were 12 Swarm storage chassis, and all of which were configured identically. And along with that, a little background on Swarm. Swarm is built around a pure object storage architecture that's simple, symmetrical, and doesn't rely on traditional storage technologies such as caching servers, file systems, RAID arrays, or databases. And automatic load balancing of requests use a patented algorithm that allows for all nodes and all drives to be addressed in parallel, removing the need for external load balancing and front-side caching, which can present a significant performance challenge in HPC environments like this, where total aggregate throughput is the goal rather than single stream performance. And the high levels of performance achieved in this environment resulted from the elimination of networking storage bottlenecks. Moving on, we will go dive into the testing methods for object performance. And when performance testing, if possible, we like to use standard testing packages and tools instead of homegrown tools so that we can provide real-world results instead of potentially inflated and misleading performance metrics. In this case, CosBench was chosen by the STFC as a tool to use during the proof of concept process where various object storage technologies were being compared. CosBench itself is an open source distributed load testing framework, and in this case, we used it to drive the S3 storage API. Now, it is very important to know the limitations of your testing tools. For example, in this case, CosBench had no error recovery code was implemented, so a single HTTP error of type 400 to 500 would stop the entire test workload. And we had to work around this by splitting the writes in the prepare phase from the reads and cleanup. As well, CosBench reports average throughput, which includes the ramp up and ramp down phases. So it helps to have other bandwidth monitoring tools like InLoad or to analyze the detailed output afterwards from CosBench and eliminate the ramp up and ramp down periods. And eliminating the ramp up and ramp down periods in your results will actually show sustained throughput on the network. And as well, CosBench was missing some of the newer S3 API features, which included authentication methods, parallel multi-part writes, and parallel range reads.
So Q, would you characterize the testing here as testing sustained throughput or testing a bursty throughput or a short-term maximum?
Okay, it was sustained over long term to make sure that these were real throughput numbers and versus sunspots or anything bursty that we might see. These were sustained numbers.
Thanks.
Sure thing. I was going to go through that in the next slide, but we're actually working with 2 gigabyte files in this case with 5.2 ratio encoding. All right. Moving on with object read and write results with increasing users. The S3 performance requirements were set by the customer, and since their use case is research data that is typically written once, for example, satellite data, and read many, many times, the read rate had to be equal to the current file system read performance. And they required 40 megabytes per second per hard drive. And for a testing environment, that worked out to be 21.5 gigabytes per second. The write rate wasn't as important, but they wanted it to be 30% of the minimum read rate. And the testing was conducted, as I said earlier, with 2 gigabyte files stored with 5.2 ratio encoding, with client threads spread over 20 client machines. And as you can see in the slides, as we ramped up the thread count across 20 clients, the performance requirements were easily met and surpassing the read goals by 63% and the write goals by 92%. Moving on to the next slide.
So Q, we were using CosBench here, and that was preferred by the customer. Are there other ways to test Swarm that you would recommend, or would you recommend CosBench as sort of the standard or best case?
CosBench, I wouldn't necessarily call it the best case, but it is a standard, and standards are good to use when you want to compare apples to apples with our numbers and competitors' numbers. In this case, we use CosBench with the S3 API. We also have a plugin for Swarm if you want to talk to Swarm natively with CosBench. Additionally, with that, since we do speak S3 or HTTP, you can use a lot of standard S3 or HTTP test tools to work with our products.
Okay, thanks.
Sure thing. And moving on to test methods of NFS performance. Now, NFS performance was important because as users transition over from file system-based access to object, they need to be sufficiently supported during the transition period. Swarm NFS is a front end to the Swarm object storage cluster that allows clients to read and write via NFS. In this test, a single Swarm NFS server was used with up to 16 physical clients using 10 gigabyte test files. The file system testing tools such as Bonnie++ and IOZone were found not appropriate in this case, and so they chose to use standard file system test tools, file system tools of TP for write and DD for reads. The performance requirement was based on a single Swarm NFS server instance, but in the field, multiple Swarm NFS servers can be deployed for additional throughput. And remember that when recording test results, not only are throughputs from the test tools used, but also external tools such as inload and beanstat are used to ensure that the client throughput is as reported. We want to make sure that our test tools are reporting truthfully. Read results.
Okay, so
yes, sir.
So these are megabytes a second, and they can be aggregated up to the gigabytes per second. What about IOPS? We see IOPS used and quoted pretty often in the industry literature.
We do. IOPS, or input-output operations per second, they can be useful for hardware vendors that have absolute limits that they can report. But in software environment, IOPS tend to be less useful since software results tend to carry varying data payloads. And as the data payloads vary, IOPS will change pretty wildly. And so actual throughput tends to be a more useful measure when end-to-end software scenarios are involved.
So throughput's more appropriate for end-to-end testing of many components, and IOPS is more appropriate for single component testing?
Absolutely, absolutely.
Okay, thanks.
Sure thing. And with on the slide for single server read and write results, with the NFS, the read results, like I said, this was with a single Swarm NFS server, and we can add additional Swarm NFS servers for scalability, but for the single Swarm NFS server, the best single read operation result came from a single physical NFS client using a single DD operation. That was 349 megabytes per second. But the best multi-operation result came from 8 physical NFS clients running 1 DD operation per client. So it had 8 concurrent 10 gigabyte reads, and that resulted in 1,562 megabytes per second, which averages out to 195 megabytes per second per read operation. And for writes, the best single write operation result came from a single physical NFS client with 1 CPU write operation, and that resulted in 392 megabytes per second. Best multi-operation result came from 8 physical NFS clients running 1 copy operation per client, so we had 8 concurrent writes of 10 gigabyte files. And those concurrent writes resulted in 1,280 megabytes per second, which averaged down to 160 megabytes per second per write operation. And as we see,
just a quick thing I'm noticing here too, Q, is a lot of times when I see NFS results reported, people are they're quoting rates, bursty rates of a short workload. This is more of a sustained workload as well, correct?
Yes, these were sequential writes and reads of 10 gigabyte files. So this wasn't these weren't bursty. This was actually the throughput of the entire end-to-end run of those 10 gigabyte files.
And to be clear, is this writing to an intermediate store and forward NFS cache, or is this writing all the way back through to the storage cluster?
This is all the way to the storage cluster and back. Swarm NFS is just a protocol converter. It doesn't do any caching or any spooling. So any writes or reads through Swarm NFS go straight to the cluster and back. So there's no intermediary. It's just a protocol converter, no caching, no spooling.
Okay, great.
And on to some performance test tools and tips. That was it for our dive into our performance study. So I'll wrap up my portion of this webinar with a little bit about different test tools. And with performance testing, we more often than not want to measure performance under a load. One thing to consider is if test tools use synthetic generated data or real previously generated data. Both have their pros and cons. One thing to watch for is caching effects if data is reused. And another thing is how verification on the back end of the stored data is performed if synthetic data is used, because we have to verify that the data stored is actually correct data. Tool selection of free and open source versus closed commercially paid software usually comes down to budget, features, and usability. Choose the one that best fits your needs, and remember if that time is a valuable resource, and a free tool that's hard to use is expensive. And when possible, we do try to use publicly available test tools since they tend to be portable enough to use at a customer site and report metrics in a way that can be used to compare with other competitors if needed. But in some situations, there may not be a tool readily available to test exactly what you're looking for, say a custom API or needing a particular workload. And using a custom performance testing tool is perfectly viable and sometimes absolutely necessary. regarding particular tips, if you have usability into your clients and servers, it's good to use third-party monitoring tools to verify what your performance testing tools are reporting. While usually not necessary, when running benchmarks for paying customer or to publish, it's better to be safe than sorry. And in that respect, it's also good to make sure that the metrics you're reporting are actually useful. And one last thing, and I can't say this enough, we only use metrics that are repeatable. Only use metrics that are repeatable. One-off sunspots do not count as performance measurements.
Sometimes that's wishful thinking, though, right?
It is, and we see it happen, but you can't. If it's not repeatable and not sustainable, you can't report it. And for me, that's it. So if there aren't any other questions, it's back to you, Ryan.
Well, thank you much, Q. And thanks everyone for joining us today. To keep up with Koringo, follow us on Twitter, LinkedIn, or Facebook. If you have additional questions or would like to schedule a custom demo, please email us at info@koringo.com, or you can click yes on the polling question you see on your screen. I'd also like to invite you to join John Bell and Eric Day for next month's Tech Tuesday webinar, What Your Storage Vendor Isn't Telling You About S3. So thanks everyone for joining us. We absolutely thank you and look forward to seeing you next time.
Thanks, everybody. Bye.